Okay, here come with the logic gates. Now, what are the logic gates? Like as we know, like if you can see the definition, so it's clearly written over there that these are the basic building blocks for creating any kind of electronic circuits. Just like if I ask you guys that what is the basic requirement for creating up any kind of the building, so you will be answering me that the basic requirement for creating any sort of the building is with the, you may say the blocks or the bricks or the iron whatsoever. Okay, these are the basic requirements to create up that particular building. But when it comes to the logic gates, or when it comes to the circuits, electronic circuits I'm talking about, now it might be any sort of the electronic circuits. It might be the circuit for a refrigerator, it might be the circuit for any electronic appliance, it might be the circuit for your cell phones, or it might be the circuit for remote control or any such thing. Okay, so for creating any such thing, or you may say for creating any such electronic circuit, so the basic requirement over there will be logic gates. Now, always do remember that when it comes to the logic gates, so in all, there are 7 different types of the logic gates. And they are, as mentioned over here, these are the AND gates, NAND, OR, NOR, XOR, and XOR or XNOR, and finally it comes with the NOT gate. So out of these gates, the NXOR or the XOR gate, now this is not the part of the course outline till your A levels, that means till your A2. Okay, so just put up a cross over there. Now, can anyone answer me that if I'm going to have a symbolic representation for the AND gate and the NAND gate, what is the basic difference that you guys can figure out when it comes to the symbolic representation of the AND gate and NAND gate? Yes,
There is a circle.
a circle, a dot or a circle. So that is the reason that NAND gate is also known as the bubbled AND gate. It is also called as the bubbled AND gate. Okay, now in the NAND, what do you think this N stands for? In the NAND gate, what do you guys think this N stands for? Not. It stands for the not AND. It means not AND gate. Not is basically an inverter gate, as you guys have just mentioned over here as well. Let me just give the description of this as well. So as you can see that I do have mentioned over here for the NOT gate that it is simply an inverter gate. That means whatever the value that you are going to input in it, it will give you the reward of that. So similarly over here, when it comes to the NAND gate, so NAND gate is the reward of the AND gate. Anything that you are going to put up in the AND gate, NAND gate will give you the reward of that. Okay. Now having a look on multiple, you may say, gates, what can you find that how many inputs are there for each gate? There are 2 inputs for the each gate, and how many outputs are there for each gate? Single output. Are there 2 inputs for each and every gate?
No.
Okay, there are 2 inputs for each gate except for the NOT gate. The NOT gate is the only gate that is having a single input and a single output. Always do remember that these gates may include any number of the inputs, but they will only have a single output. Whereas the NOT gate will only have a single input and a single output. Is that clear?
Yes, sir. Yes, sir.
Just give me a second, please. Okay, now we're coming towards the AND gate. AND gate says that output will be high if both or all of the inputs are high. That means output will be 1 if both or all. Now, what do you mean by that? Both or all simply means that, as I told you, that these gates may have 2 inputs or maximum any number of the inputs. So that's the reason I do have mentioned over here that that the output will be high, that means output will be 1 if both or all of the inputs are 1. So if you can see the Boolean expression, that's A dot B, that's a Boolean expression, whereas the logical expression is A and B. You guys need to mention the logical expression, but the thing is that I do have mentioned a Boolean expression as well, so that in case by chance you are asked with the Boolean expression, so you should know that what are the Boolean operators for each and every gate. Okay, now coming towards the truth table. So while I asked you guys to note this down, Wase asked me, sir, आपने A और B के input के sequence गलत लिखा है. The reason behind is it should be in a particular manner 0 0 0 1 1 0 and then 1 1. Is it so? ठीक है. अब मैंने 0 0 0 1 and then I placed 1 1 and finally I placed a 1 0. मैंने ऐसा क्यों किया? Any idea? Arwa, Ashina, Sakina beta, Abdullah, any idea beta? Why do I mention the inputs in a pattern that 0 0, after 0 0 I place a 0 1 and just after the 0 1 I placed a 1 1 instead of 1 0. Any idea for that? No idea?
No.
I have mentioned over here SR flip-flops. Now this is basically the part of the A2 course. You will be, if you guys opt for computer science in your A levels, so in your A2 you will be learning about the SR flip-flops. Okay. Now it says the circuitry says that if both input values are changed simultaneously. Now what do you mean by that? Like for example, from 0 0 when we are coming to 0 1, how many input values were changed at a time? Only single value, that was for B. Now, if from 0 1, I will be going towards 1 0. So how many input values will be changed at a time? Two values will be changed at a time. So that's the reason that instead of 1 0, I move towards 1 1, and then after 1 1, I move to 1 0, so that it should not give me an undefined state. On your level or in O levels, we can consider after 0 1, we can consider 1 0. The reason behind it is because it's mentioned in your book. But when you will be learning your A levels or A2 levels, so you will be finding out that changing two values simultaneously may give you an undefined state. That's the reason I haven't mentioned over here 1 0 just after 0 1. I have mentioned over here 1 1 instead of 1 0. Is this point clear to all? Vase, clear beta?
Yes.
Abdullah, Arwa, Ashina, Sakina beta?
Yes, sir.
Okay. Ashina?
Sir.
Okay, good enough. So now we can move ahead. So for the AND gate, it says that only for the 1 1 we will be getting a 1, otherwise it will be a 0. So in third part it was 1 1, so that's the reason we got the 1, otherwise it's a 0. Now the NAND gate says that output will be low. That means output will be 0 if both or all of the inputs are high. Now you may see that over here it was mentioned output will be high if both or all of the inputs are high. But over here it's mentioned output will be low if both or all of the inputs are low. So you may see that there is a revert over here. Now for the Boolean expression, you might experience that there is only a bar that is placed over A dot B. This bar represents a NOT gate. Always do remember that this bar represents a NOT gate. So A dot B, it's having a bar over it. That means it's a NOT gate over the AND gate. Okay. Then for the logical expression, you just simply need to write the name of the gate, A and AND B. For 0, 0, it's a 1. For 0, 1, again, it's a 1. Now for the 1, 1, previously for the AND gate, it was a 1. Now it's a 0 over here. And finally, 1, 0, it's a 1. Clear till here, guys? यहाँ तक क्या समझ में आ गई है?
Yes, sir. Yes.
Okay, now we're coming towards the OR gate. Now for the OR gate says that output will be high. That means output will be 1 if any or all of the inputs are 1. If any single input is 1 or all of the inputs are 1, in that case, you will be getting a output as a 1, otherwise it will be a 0. For the Boolean expression, it says A and then a plus symbol over here, B. For the logical expression, A or B. Truth table, it says AB and A or B. So for AB, it will be a 0, 0 will be a 0. And for any other thing, it will be a 1. The NOR gate says output will be low if any or all of the inputs are high. Just a revert of it. So in this, we may see that only for 0, 0, it's a 1, otherwise it's a 0. Whereas when it comes to the XOR gate, so XOR gate says that output will be 1 or output will be high if the inputs are dissimilar. Now, what do you mean by the dissimilar? Dissimilar means that both or all of the inputs should not be the same. That means not all the inputs should be 0, not all the inputs should be 1. It may be either 0, 1, 1, 0 in this format. The Boolean expression for this is A, B, and a plus symbol and a circle over a plus. So you may see for 0, 0, it's a 0 again. For 1, 0, it's a 1. For 0, 1, it's a 1. And finally for 1, 1, it's a 0. Coming towards the NOT gate. The NOT gate says that it is simply an inverter gate. Or whatever the value that you are going to place in it, you will be getting the revert of it. Only two values can be input because it's a Boolean 1. So for 0, it will be a 1, and again for 1, it will be a 0. Now we're coming towards the types of the questions. So we do have 3 types of the questions that are given to us over here. Circuit to statement. You will be given a circuit and you need to write up the statement. Statement to circuit, mostly will be getting this one. That you will be given a statement and you need to draw the circuit out of it. And truth table is a sort of a mandatory, but not mandatory. Completely not mandatory. But most of the times you will be experiencing that you will be getting the question for it. Okay.
सर बोला आता है क्या कि ट्रूथ टेबल से जो स्टेटमेंट बना रहा होता है
K-map. That's for the K-map. You will be doing that truth table say statement. You will be experiencing that in your A2 level.
Okay.
Okay. Now circuit to statement. So first of all, draw up this circuit. And then I can explain you that how we get this answer. So first of all, just draw this circuit. And as soon as you are done with the circuit, drawing the circuit, please let me know. Have you guys drawn the circuit?
Yes, sir.
Okay. Now let's see that how we can make our circuit a statement out of it. Sorry. So first of all, we need to have the output. What's the output? It's X. So we always do assume that output and input by default are on 1 or in the high state. We assume that input and the outputs by default are in the on state or is in high state. Okay. So I do have mention over here if X equals to 1. Now what do I need to do further? Just hold on. So if X equals to 1, now what do you need to see? You need to see the first gate. Now what is the first gate over here? This one is the first gate. This is the AND gate that is applied over here. So I'm gonna write over here AND. Now AND is applied between what two variables? Yes, any idea? AND is applied between which two variables?
A and B.
Okay, the first variable could be the A. I do have mentioned over here A as it's coming from this point. But the other input is coming from the NOT gate. Is it so? The other input is coming from the NOT gate. So I do need to write NOT. NOT for what? NOT for which variable? For B. So I need to write over here NOT B. Now just after that, am I clear till over here, guys?
Yes, sir.
Okay, so we need now just after that, it's going into the XOR gate. In which gate? It's going into the XOR gate. Now the other input for the XOR is coming from the OR gate. Now OR for what? One input is coming from the B, as you guys can see over here. Okay, it's coming from the B. And the other one is coming from the NOT. But not for what? Not for which variable, guys? Not
C.
for C, very good. Not for C. So in this way, we just understood that how we need to write up the statement out of the circuit. Is this clear? Any issues?
No.
Okay, great enough. Now just draw the other circuit. This will be a difficult one for you. Okay. I'm drawing the circuit, draw along with me.
Second one example है ना?
Is an example. Okay, now try to make the circuit statement out of this and we can discuss it. Come on, be good. Okay, I'm sorry, I just forgot to label the output. It's y over here. So obviously you need to start with if y equals to 1. Now what will be the further?
सर ये y is equal to 1 या फिर x is equal to 1 हमेशा यही रहता है.
आउटपुट हमेशा बाय डिफॉल्ट 1 पे होता है. आउटपुट और इनपुट हमेशा बाय डिफॉल्ट 1 पे होगा. Okay, so let's see how are we going to create it. वहां से बना ली बेटा? Okay, if x equals to 1, so what is the first gate that is applied over here? It's the AND gate that has been applied. And now where are the inputs coming for the AND? One is coming from the A and the other one is coming from not B. Clear? Now this is going into the OR gate. It's going into the OR gate for this one. Okay, now the other input for the OR is coming from again not B. So we can have a bracket over here and here. Now the inputs are going into the XOR gate. And the other input for the XOR is coming from not C. Is this clear to all? Is this clear to all?
Sir, how do we know where to place the bracket?
For each and every gate, you need to place up a bracket. Like for example, the first was for the AND gate. Okay. The other one is for the OR gate. This complete is the entire for one input, and this is the second input. That's the reason that I placed one bracket over here and the other one is over here in this pattern. Clear? And-
So why didn't we do this for the third one?
This over here. XOR. We placed up over here XOR. Okay. One input for the XOR was coming from not C, so I placed a bracket over here. And the other one is coming from the entire this one. So I placed up a bracket over here.
Okay.
Got
Thank
it
you.
now? So that's all for today. We will continue in
Yes, sir.
the next class. Thank you so much, guys. Hafiz.
Allah